let's look at naive Bayes. So there's two key assumptions of naive Bayes. One is assuming features are independent, which in reality is actually a strong assumption and hard to get. And then you also assume each feature importance is the same. So before we go to our example, let's also recall Bayes' theorem. So Bayes' theorem is essentially a probability of y given x is equal to probability of x given y, probability of y divided by probability of x. So let's now jump into an example of wanting to use Bayes' theorem. So let's say in our example, we want to predict whether you're going to go to the beach. So yes, you're going to go to the beach. And in terms of factors that determine whether we go to the beach or not, let's say different weather factors. Let's say rainy. Other options are it could be sunny, it could be cloudy. But in our example, it's rainy. Let's also put in some temperature aspect. Let's say it's hot. Other possibilities might be warm, cold, say mild. And last factor that we'll consider, let's say it's windy versus calm. So the question is, what's the probability of going to the beach in the current weather? In current weather X, where it's rainy, hot, and windy. So let's calculate first probability of yes, beach, given X. This is going to be equal to, so leveraging Bayes' theorem, rather than a single X, we actually have a full vector, or three parts of our X. But let's work on the simple part first. Let's put the probability y, probability x, let's put that in the beginning first. So probability y is probability of yes divided by probability of x. X is going to be all three of these. So let's now put in the more complicated part, which is probability x given y, and we have a whole series of x's. So this is going to be probability of our first x is rainy, given that yes, you go to the beach. Let's say yes, beach. Let's be a bit more shorthand now. Probability of hot, given yes. Probability of windy, given yes, going to the beach. So this is going to be the probability of yes going to the beach, given our current weather. Next part of this question is, hey, are you going to go to the beach? So one option is yes, the other option is no beach, given x. And let's get the simple part first, which is going to be probability no divided by probability of x's. And then let's get to the more complicated part, or the longer part. So probability of rainy, given no, probability of hot, given no beach, and probability of windy, given no beach. So at the end of the day, we're going to come out with two probabilities, one for yes, given the weather, the other one for no, given the weather. And in that case, you're going to compare those two probabilities. They don't necessarily equal to 1, so that's why you need to calculate them individually. Whatever is the larger probability will signal whether you're going to the beach or not. This is also something you could use for, say, spam detection, like email spam, spam detection, where you can calculate the probability of, say, spam or not. And your X may contain like a vector of words. So vector text, comma words that are in your email. And yeah, that's an example, short example of naive Bayes.